Hi, good day to every one of you. My name is Rajesh Segran. I am an USM University Science Malaysia Pulau Pinang student. This is my metric card, JP965515. I am a third year student. I am taking this JIM 319 Vector Calculus. First of all, I would like to thank my professor, Dr. Ashrafman, for guiding me in this vector calculus subject. I'm very happy because I have learned a lot of new things in this JIM 319 vector calculus. And today I have been very lucky because I was given an opportunity for my assignment 1 to create and present a video titled Vector Valued Functions Motion in Space. Let us not waste any more time. We will go through the slides that I have prepared. Vector valued functions, motion in space. Now, if you look at the domain of a set of real numbers, we understand that the range of vectors are mirroring the set of vectors. Alright, so we must understand that if you look at the definition that I'm going to show in the next slide, a vector valued function or vector function consists of real numbers and a range of a set of vectors. This is because each number input gives a vector output. For example, let us look at the RT, t I plus negative t square, alright, 5j, okay, provided R substituted by 0, R substituted by 2, and the R also substituted by negative 3. Okay, and this example was taken from Wikipedia vector valued functions. Alright, now let us look at the general formulation of vector in motion in space. Position vector. It's a straight line with an end on a fixed point, whereby the other end of the point having a moving point. The motion of the point forms the position vector. Thus, the position vector will change its length or its direction, or in both length and direction. Alright, what we understand here is, let's say you have a straight line. You must understand that the straight line comes from 2 points, and this point in this position vector, we have one point which is not moving and the other point which is moving. So as it moves, it forms a 360 degrees as well as 3D dimension all over the movement, or we call it motion. Alright, let us look at the speed. Speed is a scalar quantity in which its rate of change is determined by the distance traveled by an object producing speed of an object in a particular direction. If there is a moving car, we must understand for every distance that the car moves, that is the distance which is divided by the time taken, and that produces speed. Alright, let us look at the next slide. Okay, in this next slide we are going to see velocity vector. Velocity vector determines the rate of change of the position of an object, in which its magnitude is the speed of an object, whereas the vector direction gives its direction. Alright, and we also have another general formulation, which is acceleration vector. The rate at which an object changes its velocity is the object that is accelerating when it is changing its velocity. So when we have a speedy moving car, you must understand that the car, when it is moving at a high speed, it already has enough velocity. But as the velocity increases from initial velocity to final velocity, we understand that there is an initial time as well as final time, in which you need both these datas, okay, in which if you divide the both data, for example, final velocity minus initial velocity divided by final time minus by initial time, you can get the acceleration vector. Alright, okay, followed by the next slide. Alright, vector valued function in R cube. Okay, for example, I've taken this example from Wikipedia as well. In the plane R in bracket t equals to f in bracket t I plus g in bracket t j. Alright, so we have this in one equation, alright, or we can call it in one group. In space, rt equals to ft I plus gt. Alright, so that is the final equation that we will get. Alright, and now I have another example which I would like to share with you all, okay, which I have taken from Wikipedia as well. Okay, let us look at this example one. Determine the domain of the following function, rt equals to cos t ln 4 minus t square root t plus 1. Okay, what will be the right solution? The first component is defined for all t's. Okay, then the second component is only defined for t less than 4. Okay, the third component is only defined for t more than negative 1. Putting all this together gives the following domain, which is negative 1, 4. This is the largest possible interval for which all three components are defined. So you can easily understand what is the function and what is its application and how we can solve a given question involving vector calculus, especially in vector valued function motion in space. Alright, that's all for today. This is the video that I've produced, and this video will be helpful for those who are a student taking JM 319 vector calculus. Right? Okay, that's all for today.